Excuse me. Okay, this is the grade 8 PR2 final on algebra. There are, I believe, 20 questions. 28 questions or 20 questions? 28 points, but 20 questions. So the first 4 questions were true and false. And I thought I was fairly clear that if you put true or false, you have to have supporting information to prove why you believe it's true or why you believe it's false. And if there is no supporting detail, or your supporting detail doesn't make sense, I tried to mark the question wrong. So pay attention to your details. So the first question says, when expanded, the constant is 6. So this is really distributive property. And when I think about what this means negative 2 multiplied by x and negative 2 multiplied by negative 3. And negative 2 multiplied by x is simply negative 2x. And negative 2 multiplied by negative 3 is a positive 6. So when I expand those brackets, I end up with negative 2x plus 6, not minus 6. So is the constant 6 when expanded? The answer is true. It is 6. It's not negative 6. It is 6. Question 2 says the coefficient in the equation, and I'm going to say x over 4, is 1. The coefficient is 0.4. Well, no, and it's not 4 either. It's not 4. So the answer is false. And what this really is, this is a quarter of x, or a quarter of x. So the coefficient is really 0.25 or a quarter. Okay? So when we talk about how much of x do you have, that's what the coefficient does. It tells you how much of x you have. And you don't have 4x. You don't have 4/10 of x. You have a quarter of x. So your coefficient is a quarter, or 0.25. In question 3, it says in the equation negative 2 equals 4x minus 3, the most efficient first step is to add 2 to both sides. Well, you can add 2 to both sides, and when you do so, you would have 0 equals 4x, and this would become minus 1. But it's not efficient to do that, so we don't. We realize that if we want to isolate a variable in an equation, what we need to do is understand which part the constant is, and in this case, the constant's minus 3, so our most efficient first step is to add 3 to both sides. And then, of course, our next step would be divide both sides by 4, and x would equal a quarter, but you don't need to go that far. All you had to do was say, what should I do first? It's not add 2, it's actually add 3 to both sides. So your answer is false. And in question 4, when x is negative 2, the value of the expression, this expression here, that expression will have a value of 0 if x is negative 2. So what you have to do is simply write your expression and substitute the value negative 2 for your x. So negative 5x is the same thing as negative 5 times negative 2. Negative 5 times negative 2 is a positive 10, and 10 minus 10 is 0, and therefore, since it does say 0, it's true. If x is negative 2, this expression will have a value of 0. Question 5, we get into our one-step, two-step algebraic equations. The first one is a one-step algebraic equation with just a constant. It says 5 plus what number is 2? Now most people by inspection would know that the answer is negative 3. But since it's a positive 5, I'm going to subtract 5 from both sides. X is isolated. And the sum of positive 2 and negative 5 is negative 3. Okay? Now, what all of you should have done, and very few of you did, was check your answer with substitution. There was only one student in this entire class, one, that checked their answers on every single question to see if it was correct. So we have a class of 25 students. That is 4% of the class checked their answers. So what you should do is then substitute what you have for your value of x where your x was and see if that's true. And 5 plus negative 3 is 2. So I validated my solution by substitution. In the second question, this says negative 5x. Now, over half of you got the first question wrong. And I don't know why, because it's not a hard question. This says negative 5 multiplied by x. So I'm multiplying x by negative 5, and I know that I have to use opposite operations. So if I'm multiplying by negative 5, dividing by negative 5 on both sides will be the opposite operation. And I'll be left with x equals whatever 5 divided by negative 5 is. Well, 5 divided by 5 is 1, and opposite sides would be a negative. A lot of people added 5 to both sides and got 0. And I'm not sure why you did that. So your answer is x equals negative 1. And again, what you want to show here is if I want to say divided by negative 5, I do not want to write it like this. If I have a 5 and I want to show divided by negative 5, I want to have this represent this. Okay? I want to use that line to show division. Okay? We want to have continuity to our answers. Question 7 is still a one-step. This time it's only the variables on the right. So it says this is really negative 5 is equal to a negative half, or x, I can rewrite it like this, x divided by negative 2 if I wanted to rewrite that question. The opposite of dividing by negative 2 is to multiply by negative 2. So I'm going to put a bracket negative 2 and a bracket negative 2 to show multiplication. And I'm going to put a line through it to show those are opposite operations. X is by itself, and the product of negative 2 and negative 5 is positive 10. Question 8, we have one step. This one's through a lot of people. If I was to give you 4x equals 8, I think everybody in grade 7 would be able to say, well, I divide both sides by 4, and I get x equals 2. But if I was to say negative 4x equals 8, in grade 8, we would divide both sides by that, and we'll get x equals negative 2. But in this particular question, we have negative 4x, but if we don't have it equaling 8, we have it equaling negative 3. And I'm going to divide both sides by negative 4. And I'm going to put my x equals. And now all I have to do is figure out what 3 divided by 4 is. And it's not that hard because you just have to think of it as being a fraction. Because 3/4 is a fraction, is 0.75, which is the same thing that 3 divided by 4 is. It's still decimal 75. So 0.75, a negative divided by a negative will give me a positive answer. So my answer is x equals 0.75. If I substitute it back into my equation to check my answer, I take my calculator. 4 times decimal 75 is 3, and a negative times a positive is a negative. Question 9. I have a two-step algebraic equation, and when you have two steps, you still can do whatever you want to do. If you want to divide both sides by 3, that's fine, but you're going to divide every term by 3. So since we're not real comfortable at that yet, we're going to get rid of our constant first by subtracting 9 from both sides, leaving me with negative 3x equals, so many people can't add integers. 6 negatives and 9 negatives make 15 total negatives. And sometimes if we were to draw it, it's much easier to see. So there's negative 3x. So we have negative 3x plus 9 equals negative 6. And if I subtracted 9 from both sides, it would look like this. These would become 0 pairs. But what I clearly see here is that I don't have a changing here. I have negative 6 plus negative 9. I have negative 15 as my value on the right. And now that I have that, the modeling kind of falls short because dividing by negative 3 doesn't make sense from a modeling perspective. And I have x equals whatever negative 15 divided by negative 3 is, which is a positive 5. If I check my answer, this would substitute 5 for x. I'd have negative 15 plus 9. 15 negatives and 9 positives make 6 negatives. Negative 6 was the value when x equals positive 5. Question 10, we have 10 minus 2x equals negative 20. So my constant is a positive 10, and again, I would see that best if I was to draw it, and I'm not going to because I'm too lazy. But we would see that as being a positive 10. So I'm going to subtract 10 from both sides. Now, the poop hit the fan twice here, because the first thing is, so many people made a mistake with this. 20 negatives and 10 negatives are going to make 30 total negatives. And when this becomes a 0 pair, what you are left with is negative 2x. A ton of people put 2x. Don't forget, if I was to model that, it's negative 2x like this. So positive 10, I guess I am going to draw it. Positive 10 minus 2x looks like that. And when I get rid of the zero pair, I still have negative 2x. Divide both sides by negative 2, and x will equal a positive 15. Substitute to check. X is positive 15. This would be 10 take away 30, because 2 times 15 is 30, and that would be negative 20. Question 11, we have a two-step algebraic equation. My constant is positive 5, so I'm going to subtract 5 from both sides. A lot of people made a mistake here. 1 negative and 5 negatives is 6 negatives. What's left over here is a negative third of x. I'm then going to multiply both sides by negative 3, and x is left. The product of negative 3 and negative 6 is a positive 18. If I substitute to check, positive 18 is where x is. So negative 1 equals 5 plus, that is going to be negative 6, and 5 plus negative 6 is negative 1, so my solution is correct. In question 12, two steps, constant first. A negative eighth of x is equal to negative 3. Don't forget 1 negative and 2 negatives make 3 negatives. Multiply both by negative 8. And x will equal 24, positive 24. Question 13 is your first distributive property of the test. There's two of them. It says two groups of x minus 7. So there is a group of x minus 7. And there is another group of x minus 7. So this is two groups of x minus 7, or 2 times x minus 7. And that is equal to negative 12. Okay? So when I really reassess what this side is really saying, two groups of x minus 7 is really two x's and a minus 14. This is called expansion, and we see it when we put these arrows here. 2 times x is 2x. 2 times negative 7 is negative 14. So we have 2x minus 14 equals negative 12. And then it would just be a grade 7 question where I would add 14 to both sides. I get 2x equals the sum of negative 12 and 14. Remember, the reason why we're adding 14, the reason why we added 14 to both sides is because I wanted to get rid of this constant right here. And I was left with just 2x on this side. But over here, by adding 14, all of these became zero pairs, all the negatives that were there, and I was left with positive 2. Looks like an alien. So negative 12 and a positive 14 left me with a positive 2 on that side. And then from a drawing perspective, I would take those two x's, divide them into two piles, and divide the 2's into two piles, just like this, and x would equal 1. If I substitute my 1 in here, 1 minus 7 is negative 6, and 2 times negative 6 is negative 12. The 14th question is distributive property, but a little bit more complex. I put the distributive property on the right, and I have a negative 2x minus 1. So with expansion, you would have negative 2x and plus 2, because a negative 2 times a negative 1 is a positive 2. Over here you'd have negative 4. Now we have a two-step algebraic equation. I'd subtract 2 from both sides. A lot of people made a mistake here. 4 negatives and 2 negatives is 6 negatives. And when you have negative 6 equals negative 2x, you divide both sides by negative 2, and x will equal 3. Make sure your answer is correct by substitution. Substitute x for 3. Negative 2 times 2 is negative 4, which is what the value should be. I made a mistake here, so I'm not going to bother. I think I gave everybody 2 points on that. Did anyone have 2 points taken off on their test? If so, see me after, and I will recredit you for the 2 points I took off. I worded the question wrong, and at the end I just said, as long as you tell me a DumDum's 11 cents, I'm okay with it. Right? As long as you told me a DumDum was 11 cents, that's fine. All right. Question 16, it says Desiree buys concert tickets to the Wlingles on the internet. Tickets are $24 each. So the first thing is x is going to equal the number of tickets she buys, or she can buy. Number of tickets. So if one ticket is $24, then $24 multiplied by the number of tickets she buys would be 24x. Because if she buys 2 tickets, it's going to be $24 times 2, which is $48. If she bought 10 tickets, it would be $24 times 10, which would be $240. But on top of however many tickets she has to buy, there's a one-time service charge of $4. So we have to have that as our constant. And in total, that is going to equal $460. When we isolate, we would have $24 times x equals 456. We take our calculator and go 456 divided by 24, and that tells us that x equals 19, and therefore Desiree can buy 19 tickets. In the modeling, a lot of people crap the bed in this one as well, because it wasn't that hard, but a lot of us just forgot how to model. The first question says -2 is equal to an x minus 4. So the first thing I needed to see was that. Then I needed to see you add 4 to both sides, because you want to get rid of the constant to isolate this variable. But you had to add 4 to this side too in order to keep them equal. Then you had 2 equals x, and therefore your solution is x equals 2. That was as easy as that. In the second modeling question, you have 4 x's represented by 4 lovely algebra sticks, and a -1 equals +3. I want to isolate the variable on this side, so I want to get rid of my constant by adding 1 to both sides. I would have 4 x's left equals 4. Since 4x has a value of 4, then each of those 4 x's must have a weight of 1, so x would equal 1. In the next question, I have a -2 on this side, and a -5 on this side, and a fifth of x, which 1, 2, 3, 4, a fifth of x looks like that. I want to get rid of my constant by adding 5 to both sides. And when I add 5 to this side, I have just a fifth of x left. And when I add 5 to this side, it makes 0 pairs here, I have 3. Now here's where things went a little pie-eyed. If I have a fifth of x is equal to 3, what I want to do is I want to multiply this side by 5. And if I multiply one side of an equation by 5, I must also multiply the other side by 5. Which means this is going to make an x, a full x, because 5/5 of x make an x. And over here, I'm going to have 15, and therefore x equals a +15. And in your last question, is it distributive property modeling? 2 groups of x minus 5. There's one group. There's another group. There's 2 groups of x minus 5, which is what this says, is equal to -10. All right. So the first thing I'm going to do is I'm going to add 10 to both sides to get rid of the constant. This is adding 10 to this side. That'll get rid of all my constant, but I have to add 10 to this side. So whatever I do to one side, I got to do the other. All of this is gone as well. So I'm left with 2x on this side and nothing on that side. And 2x equals nothing, so every x must be equal to nothing. Okay?